Okay, what we'll be showing in part 5 of the demo now is we've added 4 extra coils to our generator. The 18-pole rotor has been changed to a 6-pole rotor. What we're going to be doing in this demonstration is we're going to use the generator back EMF to accelerate the induction motor, and as the speed of the system increases, we're going to use this ceiling fan speed regulator to lower the voltage to the motor, and then we're going to shut off all the coils, disconnect the load, and the system will slow down. We'll keep the ceiling fan switch where it was, and we'll let the motor run the system on its own, and we'll be able to draw a comparison between employing back EMF and the motor driving the system completely on its own. So I will start it now. So I'll start the generator now. So what we have here is, again, all of our individual generator coils are listed from 1 to 8. Using a ceiling fan switch here to accelerate or decelerate the motor, set a stable speed. Right now, coil 2 is at about almost 160 volts. And I'm going to gauge all the coils now. Good. I guess you can hear the system accelerating. Lowering the input to the motor here slightly. Continuing to accelerate. Coil 2 is at 257 volts. Our input to our motor is 80.1 volts. I have the rheostat set. I'm going to disconnect all of the coils. As you can see, the voltages, the no load voltages to coming from our generator are dropping. The power going to the motor is increasing, and the system is slowing down. Right now, we're running the system on the induction motor alone, and without the back EMF, the induction motor doesn't have the power to even keep the system going at all. 255 watts going to our motor right now, and we're producing, well, from coil 2, 0.8 volts. Okay, what you just saw, essentially, we were accelerating our prime mover induction motor with generator back EMF and motor power. And what we're going to do now is we're not going to introduce any back EMF into the system. We're going to accelerate the motor up to essentially the same speed that we were producing in the previous test. Coil 2 was producing about 257 volts. The motor required 235 watts of power. And now what I'm going to do is I'm going to accelerate the motor up to about 257 volts here. And we're going to take note of how much power the motor requires to produce the same no load voltage without back EMF. Forty-seven, 48, 52. Right now we're at 250 no-load volts coming from our generator, and our motor requires 280 watts. Just let it get up to 257 right on now. 280 watts. As opposed to 235. 235 watts of power required by our prime mover when we're accelerating with back EMF, and 280 watts when it's the motor accelerating the system on its own. That's good.